Yes, so I'm Simon Chassar. I'm here to talk to you about the industrial cybersecurity and protecting the industrial economy. Digital transformation and the perfect storm. It's all coming together right now, and I'll tell you why. Digital transformation is accelerating. Connected devices, IoT, the combination of automation of processes and procedures within our factories and our industrial economy environments is accelerating. Yet, the increased connectivity is leaving the OT and the IoT environments vulnerable. This is an increased threat surface. You're talking about connecting now programmable line controllers that are producing tins and beans or cars for parts that are effectively now connected within networks of the IT environments. We've been focused so much on the IT security controls, defending the IT networks. Now we're plugging in the OT networks to the IT environments. We're starting to increase the threat surface. This is a vulnerability. The cyber attacks are going up and up even more. They're increasing in frequency and impact. You can just see here from where it originally started to some of these sessions in sort of 2000 with Maruki Mortar, and how that's got all the way through to the latest attacks with Honda, for example, the ECAN snake malware. This is accelerating, and we're starting to see this combination of how these attacks and how the malactors are starting to get smart around how they build this malicious code. They're building in industrial proprietary protocols into their kill chains that are effectively able to go into any access point across laterally within the network and effectively bring down procedural processes within the industry and factories and plants. This is a new type of threat actor that is seeing that they can stop industrial systems and gain more from it than capturing personal information. We've only got to look at things like the Colonial Pipeline attack, which is a very big attack that happened in the US. The Colonial Pipeline was attacked by a malactor called DarkSide and effectively got in through an inherent risk and a vulnerability that stopped the pipeline being able to ship petroleum all the way up the east coast of the US. This wasn't just an effect on the revenues and the operations of this pipeline provider, but actually affected people who couldn't get petrol from petrol stations. So this is now impacting from the industrial economy onto us in society. This is about protecting the industrial economy and making sure that we are protecting ourselves and society and how we go about this new Industry 4.0 and how we move forward. IT can't protect what they can't see. They can see and they know the visible risks within the IT environment. IT controls and the IT innovation and controls has been evolving over the last 8 to 10 years. I think there is now more and more IT controls and providers that's getting to a point where they've got to collapse vendor consolidation. You're seeing more and more native controls come out of the cloud providers as people are moving to work from home. You know, that perimeter now is extended. So more and more is this sort of perimeter that is now everywhere to the home office. But they're still evolving and using those tool sets to protect the IT environment. And they know this and they can see this visible risk. What they can't see is the operational technology. Everything from IIoT, OT, smart buildings, grids, all the way through to all the sort of connected vehicles in Industry 4.0. There's unfamiliar assets, there are unfamiliar protocols, proprietary protocols, unpatched legacy systems, firmwares, things that are producing wind turbines that have got firmwares that are probably 10 years old. These things are, inherently risk because of the firmware that's there. It's not as easy to patch like an IT environment, where you just deploy a patch to all your IT environment and effectively you've increased your cyber posture and reduced some of the risk. Within operational technology, you've got to physically go down to that environment, plug in and update that firmware within the OT environment. This means that it's completely unknown. Also, different people are operating these two different types of technologies. The OT engineer is effectively caring about health and safety and risk and making sure that the operational processes continue. Producing, for example, the COVID vaccine, making sure that it's coming off the production line in the volumes that they expect to make sure that that supply chain is operating and being able to supply to us to get vaccinated. They make sure that the temperature gauges are making sure that they're recording the right temperatures so that then they can see and make sure that everything's being produced. They're not aware of what is happening and potentially what could happen through an unsecure access to an engineering workstation that makes a firmware update to a control at the configuration line that maybe changes the temperature, maybe changes some of the procedure outputs. This is the combination of the cyber physical systems coming together and effectively creating this vulnerability and this risk. So how are we going to address this? We've got the challenge around increased digital transformation. Every factory, manufacturer that is there is looking to optimize their environments, automate their processes, increase their efficiency. Why? Because us, the consumer, is effectively demanding more. The just-in-time supply chain, the process around how we try and do everything just as fast as we can across the world with multiple disparate systems and production environments. We're trying to optimize and using technology to do that. That also means connectivity. That means, how do I protect myself in this environment? How do I start to look at this as now an extended threat surface? There is a model that's called the Purge model, which was the traditional way in which you would segregate those physical systems from effectively the processes they proceed within the business all the way up to the IT layer. Now, this is starting to collapse. There is a caveat on this though, because what you're also seeing in terms of critical infrastructure environments, everything from energy, water, utilities, is the hardening of this Purge model because of the Colonial Pipeline attack and also the Osmar Water and many other sort of utility attacks that have been happening between nation states. There is an argument to say we need to pull that away from IT and make sure we harden that environment and control that Purge model. So that is the caveat and the exception. But as you move towards more of the, what I'd say, the verticals like digital, like heavy industry, like pharma, like automotive, like food and bev manufacturing, where they're starting to collapse IT and OT together within the network environment because they can gain that efficiency faster in terms of the connectivity. That's where it starts to open up some of the vulnerabilities, and that's where the Purge model collapses. And I think this is where we start to see some of that increased risk from an open backdoor port for a third party, whether it's a proprietary systems provider like Rockwell, Siemens, Schneider, Yokogawa, ABB, all of these companies that are accessing and keeping these asset life cycles up to date and the firmware up to date. They're all open doors in some way that need to be secured. And/or they create an opportunity for the malactor. Some of the common challenges that we see in terms of driving that optimization and to industrial cybersecurity is the infrastructure complexity. You've got a completely legacy unmanaged switches, you've got window endpoints within your industrial environments that you don't even know about, that aren't even managed. You've got air-gapped networks, you've got outsourced infrastructure, you've got a really difficult architecture that goes across multiple plants. If you think about the headlights that are being produced in one country, to the body panels being produced in another country, to the ECUs in another country, and all those factories are shipping at the right time to the assembly site and plant in another country, all of these things need to talk to each other. All the way through to the point where us, the consumer, goes into the dealership, puts in our personal information, specifies what type of car and customization that we want to that vehicle, all the way through to the factory that then orders all the parts from those suppliers, that then links down all the supply chains, and how they're all interconnected to make sure that your vehicle gets produced exactly how you want it and delivered to your door 9 months, 6 months later. Those interconnectivities of industrial systems are now critical to keeping the industrial economy moving. There's poor security. Just the people that operate the OT environments, the OT networks, haven't really had to focus around security within their industrial environments before. Whether they're blacklisted CCTV cameras or whether there's people's smartwatches connected to the corporate Wi-Fi, these things are just considerations of just the digital transformation that we are driving as consumers and of IoT devices, for example. There's the people in the organization. There's different technology stacks. There's a different technology stack within an oil rig than there is within the head office, for example, in a different country. You've got different people and different objectives, and these are some of the complexities around how to bring these two pieces together to drive that OT and IT convergence that's being forced together as part of the digital transformation, and then how do you protect all of that environment? So some of the new requirements for industrial cybersecurity that we see is a reveal. First of all, we don't know what assets we've got. We don't know where they are. We don't know what versions they are. We don't know what inherent risk we have today. How do we address that? We need to get visibility into how the assets talk to each other, which ones are communicating, what versions they are there any already unpatched environments or inherent risks that we've got we need to address, and where do we start first? Next is protect. Really understand how and who and where people are accessing my environment. Really lock down where my risks are, how do I prioritize my risks, and ultimately how do I start to drive a procedure and a change and bring together, for example, OT as the first line of defense in the 3 pillars, which effectively brings GRC, the audit committee, and the SOC together to be able to provide a controlled view around how our environment is protected. There's detect. We want to start putting indicators of compromise in, so we start to use some of the more open YARA and SNORT signatures or other type of IOCs and STIX formats. These are all sort of acronyms that you may or may not be aware of, but ultimately these are ways in which we then hunt for unknown and known threats, or APTs, advanced persistent threats. Really start to get an idea of who's attacking when and making sure that I'm monitoring that environment. And lastly, because you're talking about health and safety and risk, really when you do want to connect these environments into your IT, the connecting the people, the processes, the skills that you need, the systems, making sure that your industrial systems and the alerts that you're seeing are connected into your SIM, your security incident and event management, into your SOC, making sure that you've got that visibility. That's always the last sort of stage of this life cycle. And we're seeing these requirements come out as the maturity of the industry economy goes through this cycle of transformation. So this maturity, it's normally broken down in 3 steps. As I said, first of all, understand what I've got, the network. What assets are in the network? How is my network structured? What zones do I have? Do I have a Purge model that's complete, hardened, or is it open? What are the vulnerabilities and the risks that are present, for example? Then, controlling access. I need to know when the guy is turning up for the maintenance window, is he bringing his own device? Is he plugging it into the port of my network? Is that then open? Is he accessing an engineering workstation, which now can see all of the programmable line controllers across his competitors as well? Does he want to sabotage his investors, an insider threat sort of approach? I need to control who sees what and what they're doing when, make sure that then when I do open up a maintenance window and or open ports, I know when and how and who is doing that. And 3, detect the threats. Really understand when I'm getting attacked. Do some of that simulation, do some of that breach simulation and attack simulation. How do I deal with the fact that I now can't produce I'll go back to the vehicle analogy, for example. I now can't produce a car every 31 seconds. What happens? Do I just fill up the parking lot? Do I send all the staff work from home for the day? When do I get that operations back up again? Do I then have to pay overtime? Do I then lose customers? Think about some of those things. How do I then protect my environment and go through the simulations of what happens if my industry goes down? If we think back to that increase in vulnerabilities and threats that we're seeing and impacts on organizations, there was one there which I quite like, which was the Molson Coors one. Beer drinkers out there will also like Coors' story. In essence, the challenge they had was they shut down production. They couldn't produce the beer. From not being able to produce the beer, that also creates a knock-on effect to their supply chain and the distribution model. That then has to be restarted again. You have to get customers back to looking on the shelves and seeing Coors, and buying Coors. That's another issue that then has a knock-on effect to the business. Therefore, this then starts to become an issue which is then at the board level really critical. This is no longer around getting fined regulatory impacts or fines because I've lost personal data, or that I've had a system shut down and somebody can't use email for a day or 2. This is now, I can't produce what I need to produce to supply and service my customers. This is now critical. So clarity, where I'm from. This is our platform, end to end. This is how we protect the industrial economy. We do everything within one single platform, all the way through those life cycles and all of those requirements. Everything from vulnerability management, that inherent risk. What have I got? Firmware level depth. This is because we've got investors that are Siemens, Schneider, Rockwell, deep packet protocol information sharing. We understand this industry and this sector. Threat detection, indicators of compromises, our partnerships and technology alliances that we have with companies like CrowdStrike, etc., from an EDR point of view, allows us to really understand what some of those threats and alerts are and create those alerts from the industrial side up to the IT side. Risk management and secure remote access. This is our real differentiator from Clarity's point of view. You can now have your third-party supply chain in your industrial environment connecting in and running maintenance and firmware updates, all visible through the same platform, audited, recorded, all structured for your SOC. So you can even shadow what they're doing and what line card configuration adjustments they're doing, all within one platform. And across the protocol library, everything from IoT, OT, IIoT, IoTX, whatever it may be. And I talked about the technology alliances that we have. It's not just limited to endpoint. It goes all the way through to SIM, to cloud, firewall, network, identity. We have these technology alliances because we are the leading industrial cybersecurity provider. And the platform that we deliver is consistent and aligned from a synergy point of view around the IT controls market and how they want to understand what are the OT alerts for our deep knowledge that we have as an organization. And therefore, we build these technology alliances so that we can really provide a complete industrial cybersecurity solution that fits into your strategy around IT and your IT controls and brings all of those together to protect the industrial economy. So, in closing, as the leading industrial cybersecurity platform, we really do protect everything within the four walls of the industry, and we are protecting the industrial economy from its continued momentum on digital transformation, and to make sure that us consumers can continue to get our goods, and those in the industrial economy can continue to produce them for us. Thank you very much.
Simon, thank you.
Thank you.
There are questions, inevitably.
Okay.
I am aware that we are going straight into a panel after this, so
okay.
there may be some overlap on these questions in the panel, but that's okay. So one that's come in, with technology advancing all the time, why are cyber attacks still so common?
It's the old cat and mouse answer, I'm afraid. So even things which were invented of yesterday from an innovation point of view, people are already trying to find weaknesses in it. And therefore they're deciphering code, they're restructuring code and how it's been built, identifying, I suppose, faults in somebody else's code development work, and they're creating that. And therefore, the innovators cannot stay up and ahead. You can create patches for those vulnerabilities once they've been identified, but there's always going to be someone that's going to be trying to identify where the gaps are within anything that you create from a IT cybersecurity control.
So that's very reactive, and obviously you can fix a problem when you discover it. What can industries do proactively to try and avoid these solutions or these issues in the longer term?
Yeah, it's really having the three lines of defense. So making sure you've got your connectivity between from an industrial point of view, your OT environment is your first line of defense from an industrial side. Obviously, you've got your GRC, you've got your SOC, and you've got your audit committee. And the combination of those three things coming together to make sure that you've got the right industrial controls across all of your security control points, as well as you've got a seamless integration with what is your policies, and bringing those all together, as well as the right threat monitoring and response services that you've got on those. And I think having them all combined, and that really comes down to the nature of building in security by design, and effectively that, the word shift left, but making sure when you develop applications, you're thinking about the security as you're building the applications, whether it's black box or white box, which is effectively testing something in the code level, or whether you're testing the built code, and making sure that when you run those through to your production environments, that you're constantly maintaining them up to date and making sure they're monitored.
Yeah, someone's asked a question which I think I already know the answer to, but can industries ever completely win the fight against ransomware?
I don't think so. I think that this is the challenge. As long as there's people out there finding vulnerabilities, there will always be this catch-up having to be done and patching. The only thing that I would say personally that I think may be a game changer may be the introduction of quantum encryption.
Okay, thank you very much. So we are about 10 minutes away from our panel. I think we need to do a slight stage reset. So if we all hang around in this room in a couple of minutes, we'll have a panel with Simon and Richard from Leidos as well. Thank you.
Thank you very much.